Welcome back. We are now continuing our Unit 1, Section 4. Section 4, Combination as Counting Method. Well, by the end of this session, you should be able to explain combination as a principles of counting. Give example of situation that require the use of combination, apply the factorial notation in combination, and apply combination as a counting principle. Yes. Combination as counting method. Now, unlike permutation in which the order of arrangement matters, in combination or combination has to do with selection in which order does not matter. So we select without order, whereas permutation was dealing with arranging in order. So the number of combination of n element taking r at a time is given by the formula. Combination could be written as C combination R or NR. As you could see, I mean this. So this all can be classified as what? Combination. This is also combination. This also could be written as combination, and any of them is accepted. Now, n combination R as a formula, n factorial all over n minus 1 into bracket factorial times r factorial times r factorial. Times r factorial. Now let's quickly move on to an example. Example 1. In how many ways can a committee of 3 be formed from 8 people? So you are forming a committee of 3, selecting them from 8. The order in which they appear doesn't matter. So in this, we have n should be equal to 8 and r is 3. So that's 8 combination 3 is equal to 8 factorial all over 8 minus 3 factorial times 3 factorial. This will give us 8 factorial over 5 factorial times 3 factorial. But there's one thing I want you to note about a factorial. For instance, 5 factorial times 3 factorial is not equal to 15 factorial. You get it? But a 5 factorial on its own is 5 times 4 times 3 times 2 times 1, 120. And 3 factorial is 3 times 2 times 1, giving us 6. So you see, we cannot multiply factorials together. Well, that's not what we are discussing here, but for the benefit of those who have problem with factorial. So our solution to the example 1 will be equal to 56 if we do our algebra very well. So you see, the combination, it look quite easy, right? Yes. When we move on to other examples, we're able to get the concept clearly. Now let's give example 2. In how many ways are there for 2 students in a class of 10 to give a presentation without taking the order in which they present into account? Remember, we have this example under permutation, and you saw the way we deal with it. Here, the order is not necessary. So clearly give us a picture that this is a question of combination but not permutation. So in this case, n is 10. And since we are selecting only 2 out of the 10, then we could say that r is 2. Thus we have 10 combination 2, which will be equal to 10 factorial all over 10 minus 2 factorial times 2 factorial. And this again giving us 45 ways. Can you think of more example? In how many ways? Can 15 people make a presentation considering only 3 of them, where the order in which they make the presentation is not necessary? Can you think of the solution? You could try yourself. Thank you very much. We look forward to the next section.